Hi, it's Mr. Baumgarten, and we are going to continue with our coding quest videos, doing a walkthrough of the practice round questions. And we are up to the one from 3rd of March, Lost in Transmission. Let's take a look and see what this one involved. Now, this was a validation algorithm question where, given a message string, we had to rearrange it into a two-dimensional grid where the bottom corner was missing and calculate where the error was in the message. So the message is in this part here somewhere, in this box basically, where this is a validation verification byte. This is a verification byte, and this is a verification byte, as are all of these. So the demo one that we have here, we find that the error was the 60, I believe. I think, yes, it was. All right, so if we look here, so basically what's going on here is we need to add up all of these numbers. They are all here as hexadecimals. So if I just open up the calculator, and code this in, so we have 54 plus 68 plus 69 plus 73 plus 20. All right, that's 1B8. And so you can see here that if we mod it against 256 decimal or 100 hexadecimal, we have the B8 left. And that's what this is showing us. So that's what should be at the end of the row. This one, if we add it together, all right, it should have BD, but we can see here the original message had a 7D. So we know that somewhere in this row there was an error, and then the same thing happens by the columns, and when we add up this middle column, it adds up to that, but this is what the data had. And so where that column and row intersect, we know is the incorrect value, and we can just take the difference between what we calculated should be there and what was there as to work out what this byte should have been. Right, so how would I go about coding this? We look at the input data, and it's been given to us here in the rows and columns already, just to make it a little bit easier. The original version I had of this actually just gave it to you as one big long string like this, but I decided to simplify it a little. So let's start with the input data and then have a go at doing the real data. All right, so I'll just post that, and let's call it day 4 error checking. Well, actually, let's just call it input. That's what this is for now. And let's make up the Python file. Error in transmission, wasn't it? All right, so we'll read in the file with open day4 input.txt for reading mode. Data equals f.read.splitlines. Okay, so that's going to read it all in. And now I need it as a two-dimensional array. But where this last column is going to be one value shorter. So Now, I've used these list generators a few times. Maybe I should explain what's going on here. Let me do one the long way. All right, so we're iterating through every row, which if we print that out, okay, there's my rows. And then I want to do split it on the space for every part in that string of parts. All right, if I print that out now, I get my individual values, and then let's just put something there so that it stands out. Okay, so we can see here we're going to print the part out, and then we're separating them with this thing, and then we hit the end of the line and we've moved on to the next one. So I've got here my two-dimensional grid. All right, and so if this is the individual row, I've already got the name row here, so I can't. What I've been using before is line, okay, because it's one line of the file, and that's just because I want the word row back. If I create an empty list for the row, all right, then for each of these parts, I can append that to a row, and then once I've got all the parts there, I can append that row to the grid. And now if I print grid, we'll have ourselves a nice two-dimensional grid. All right, you can see there's one, there's the other, there's the next, and then there's the next, and then there's the second set of enclosing braces. So it's a two-dimensional grid. The only other thing I really should do is convert this from being a string into its binary number representation. So I will use the integer conversion function. Okay, and now, so we're getting the decimal value of the numbers, but it doesn't matter. Decimal, binary, hexadecimal, it's all the same thing to the computer. All right, so I can perform all my binary arithmetic on these integers, and it's all. All right, these numbers are all being stored as binary by the computer behind the scenes. All right, now I've been doing this same thing without the print statements. I've been doing this same thing as in one line in the other examples. All right, it's a two-dimensional grid for. So what am I doing? Int part base 16 for part in parts. Well, okay, so instead of parts, it's line dot split, and then here for line in data. So using the same variable names. So here, instead of taking parts, I've just got this line dot split straight in the for loop. All right, so that and that are the same thing. All right, so you can see here, I've got my outer list, and then my inner one, I'm saying, okay, for every element, so for every part produced by the line split, I want to do this with it. All right, and then here, for every line that's inside the data, I want to do this with it. yeah, it's not the most intuitive thing that Python has to read, but it's handy once you get your head around it. But I wouldn't worry too much about that. If you're more comfortable doing this, then stick with that. It's perfectly valid code. All right. But yeah, both of them achieve the same purpose. Okay, we are 10 minutes in and I haven't started the problem yet. But you know, this is a useful thing to learn. So let's move on. Okay, so I've got my values in a two-dimensional grid. I need to calculate what the checksums should be, and then see if there's an error in them. So let's do this by row. First of all, for y in range 0, the length of the grid. So the row is the grid at that y. All right, so for every row, so I want to go up to one value less than the end of the list. So what the checksum should be, start off as a 0 for x in row. No, well, let's just do it with an iterative. Checksum is whatever's inside the checksum plus that value. Now, I want to go. Yeah, I want to go up to one less than the end of it. Right, and so if the checksum is different to the one that is at the end, right, and another nice little thing with Python is the -1 basically gives me the last value in the list. Okay, otherwise I could do that. Or at the moment I would also be able to do x plus 1, but yeah. Anyway, -1. That works for Python. If you're not using Python, that's your choice. All right, so print faulty row is y. Y is the row number. That's faulty. Calculated checksum to be checksum, but received row -1. All right, and that should. Okay, yeah. Yeah. All right, so we see here we're getting 4 forward. That's because I haven't, I only want to use the modulus against Who56. All right, so after I've totaled them all up, it's only the modulus of the remainder from 256 that I'm interested in, because it was all truncated down to 1 byte. And we got 2 errors. 0, 1, 2, 3, and that's because we're including the checksum row. So really this needs to go up to 1 less than the end. We don't want to include the last row. All right, so there we go. There's our faulty row 1. I don't need to be printing the grid, but it's not there. Let's just put it up there. And I can do the same to find the column. All right, I want to go up, but up to, I don't want to include the last column, so that's why I'm taking 1 off of that. All right, and then the column is grid Yeah, okay, so this is the part that I have to do slightly differently because I don't have a y value just to plonk in here. So let's just do it manually. Go through every row in that column, except for the last one. So this checksum, let's reset it back to 0. The checksum is going to be whatever's in the checksum plus the grid at that y-x location. Checksum is now going to be the checksum of the mod 256. And if the checksum doesn't equal what's at that column, so I need the max, I do need the y, yeah, so the last y for that column, print faulty column is x calculated to be checksum but received grid -1 x. And let's see if that works. Faulty column is 2 calculated to be 60 but received 252, which if we look here, 0, 1, 2, yeah. Okay. That's 60 decimal, by the way. And this is 60 hexadecimal. I just realized I was using a different zoom level to the previous videos. Okay. So now I have found them. So let's do so the row difference is just going to be checksum minus row -1 . Alright, so I'm just finding these should be the same number. But you can already tell that they're not. All right, the amount of error should be the same. All right, one is 64 and the other is -192, which you notice is just off by 256. Okay, so we can easily fix that. So while column difference is less than 0, then we'll just increase it by 256. And for thoroughness, let's do the same to row. Just in case when we get across to the real data that we have the same problem, but that it's with row instead of column. And then move my print statements to after the while loops. Okay, now they both have the same value, 64. Now, I should also be keeping track of, I don't know, what do you want to call it? The bad row number. we need to remember what the bad row is, so that's just y And here we need to remember the bad column number. All right, and that's just X. So that we can look up the offending the grid at the bad row, bad column. Okay, so the offending byte is 96, which as hexadecimal is 60, which is the one that we knew it was. All right, so we're almost done. We've calculated the checksums, we've located the erroneous byte. The last bit we needed to do was correct the erroneous byte. Okay, because so the correct value for the byte was 20, okay, or 32 in decimal. In other words, 96, all right, is 64 too high. So we need to subtract. Corrected value, all right, is just this thing minus the row difference, or we could have used the column difference, because they're both the same thing. And provided they are the same thing, then this would work. All right, and so the correct value, oops, let's print out the hexadecimal for it as well. All right, 32 or hexadecimal 20. Okay, now the only other thing there is, just in case that took it into negative, I would probably also put that same while loop in there. All right, because we're doing a subtraction. Let's make sure we end up with a value between 0 and 256. Okay, so that works. All right, now what was the actual answer? The actual code needed us to do something with this. To find the answer to the problem, locate the erroneous byte, multiply the erroneous value by its correct value. Your answer is the decimal value of that multiplication. Okay, so answer is the incorrect value, this thing, multiplied by the correct value, all right, 3072, which I have, oh yeah, there it is, 3072. Okay, and now we should be good to go. So what I've got here matches the input example. Let's grab this. And again, because I haven't hard-coded anything in terms of sizes or anything else like that, I should just be able to paste this in and let it do its thing. 297. Woohoo! All right. This has been Mr. Ballgarden signing out.